Hello and welcome. Good morning, good afternoon, wherever you are. My name's Daniel Brown.
My name's Chris. Good morning also from my side. As you maybe see on the cameras here in Germany, it's already pretty late, but we are happy to be here with you guys. And yeah, we hope we bring you a good start into the day.
Absolutely. So we're happy that we're able to catch up with you today. Obviously, normally we're there with you at the CAT conference in, what's today? That would be the Southern CAT conference, somewhere down in the south. Unfortunately, we can't make it, but at least we've got the chance to catch up with you now. So we're actually here in our offices. We're in the showroom today, so we'll have a quick look around.
Yeah, that's basically where we also welcome guests and where we show our automotive concept. Like Daniel said before, normally we would be happy now to be in the US somewhere, have a great time there, have a great barbecue later. This time it won't work, so we have to stay here in Germany in our showroom. A little bit later, we will take a look around and yeah, that you get an introduction to our showroom here. So even if you are at the US, then we take you a little bit here to Germany and give you a slight insight. But okay, let's start with the topic of today, which is
ADAS.
ADAS system, Advanced Driver Assistance Systems. Perfect topic. Okay, before we come to the training systems, what is ADAS basically? Do you want to say some words for that?
So I guess ADAS is a number of different systems. Obviously, everyone's talking about autonomous vehicles now, but ADAS is kind of all of the puzzle pieces that fit together to get to that aim of autonomous vehicles.
Absolutely. And the thing is here, so when we are talking about advanced driver assistance systems, we all know that they have a big benefit for the driver and also for the surrounding traffic, of course. We all can imagine something under this word advanced driver assistance systems, but it's hard to see that system. Like Daniel said before, it's not like you can say, that are the headlights or the front bumper. The advanced driver assistance systems are basically integrated into the whole car, and there are just some spots at the car where they come to the surface and where you can see it from the outside. But this is like with the example from the iceberg. What you see at the outside is only a small part. So we are right now here at the very modern vehicle, Audi Q5 Hybrid, and this car is of course equipped with a lot of different driver assistance systems. Every driver assistance systems needs different components, and here are slightly some components which we can see. For example, down here where normally the fog lights are, here we have the radar system. In that version of the Audi, we have it on the right-hand side from the driver's perspective and on the left-hand side of the driver's perspective. So this is the radar system. We will later see it inside the training systems where you, for example, do the ACC with. Even at the okay, I won't do the bumper now.
Sorry, Graham.
So even at the front shield, there we see at the middle in this black area, there we have a camera. So basically you can say the camera and the radar are one of the most important components for all the different advanced driver assistance systems.
Does this car have LiDAR, Christian?
I don't think so that this car has LiDAR, because that must be also somewhere on a very central spot. So this is not necessarily that any car has LiDAR. What LiDAR is, we will hear later. So, but here we can definitely say we have the cruise control, so the adaptive cruise control. And we have, traffic sign recognition, we have lane assistance and all that. So basically that are all driver assistance systems. The question is now, how can we explain that? So when I say, for example, adaptive cruise control, everyone has an idea because he had used it in the car. But what are the challenges when we are talking about that inside automotive training?
So inside the classroom, things like that. So obviously we're trying to have a look, and on a teacher's perspective, how do you teach these topics? And where can you use a real vehicle? Where is it perhaps a little bit difficult to use a real vehicle?
Absolutely. Just let's start. I think there are two challenges which we have to meet. On the one hand, we are talking about the size, which matters in that case. So what is the problem here? In order to show and to use driver assistance systems in a classical way, we need a whole car. Okay, we have now the problem, how do we want to get a whole car like this SUV inside the classroom, for example? And on the other hand, what is even more important, even if we have one car, how can we get all the students get busy just on one car? That's much too less. And buying a car for each student, well, I think we understand what the problem is here. So we have a size problem and we have a cost problem, but that's not everything. So when we have the car, even in the classroom or in the workshop, it's hard to show how they work when they are staying there. But the even more important part is how to do diagnose and repair on it. And there we even need additional parts for it.
So one of the questions, Christian, is what's the most common kind of tasks or jobs that's going to be required for ADAS systems out in the workshops? What's the, you know, in the end, we need people to fix and repair these systems and keep them running. So
absolutely. So that's not the thing that we like in a combustion engine, where we open the combustion engine and fix the engine on single components. When there's a problem with a component of an ADAS system, you change the wiring, you change the control unit, or you change the radar component, for example. But the most important thing is, on the one hand, to understand the whole system, that you know, yeah, what component could be the problem if you do the diagnose. But the most common task for ADAS system will be calibration. And for calibration, we definitely need more than just the car. For the calibration, we need the diagnostic tester and something like what we see here. So that is, in that case, from Texas. This is a module or a calibration system for the radar, down below here. So that's like a mirror which works together with the radar sensor, and up here for the camera. And later in the training systems, we will see how this calibration works. Because like I said before, the most common task is the calibration. And we bring the calibration from the workshop and from these big parts into the classroom on each student's table. Do you want to add something?
Well, so obviously what we're looking at is the calibration, how that works, things like that. That's something that's being, like I said, probably the most common job that's needed at the moment for technicians. But I think what we're going to show today is going to show into a little bit more detail how these systems work. And as someone obviously from not from Germany, you're from Germany, but I'm from Australia. I can say that it's definitely a part of the German way of thinking when they develop training systems and do training, is to make sure that everyone doing the training gets a much deeper level of knowledge. The way they call it is system understanding. So it's really important to understand how systems work, so that you're kind of at that level where you're able to diagnose problems. So obviously calibration is going to be helpful if you're swapping out, like you said, switching out some radar parts or fitting new parts after a small accident.
Repair and collision tasks, if you just re-equip something, if you upgrade the car, if you, very important part for the younger guys, if you tune or optimize the car and you lower it, then you change the complete characteristic of everything. And it could happen that you need to recalibrate then the radar, for example, or even the camera, because you are now on a different angle towards the street.
And we're going to have discuss a little bit later about implausible signals, things like that, where the computer starts to determine, okay, the signal that I'm getting is not quite right. That's kind of, okay, taking it beyond reading out a fault in the scan tool and saying, okay, just switch out this part. It's making you going to think about where does the fault, because of course all of these systems are connected in networks.
Absolutely.
Using CAN bus, also Ethernet now in
Ethernet,
some of these systems.
FlexRay.
FlexRay, exactly. So it's really taking it to a much higher level.
Absolutely.
Okay.
And now let's move from the big smart parts to the small smart parts.
Okay. So just while we're here in the showroom, we'll just have a quick look around here. It's not something normally when we're traveling, obviously over the other side of the world, we normally just bring a little box with 1 or 2 items with us.
That's
true.
While
we're here, we've got everything. So we'll just have a quick look around. So some of the other systems that we've got here, electrical systems, obviously lighting systems, xenon lighting systems, generator systems, CAN bus, all sorts of different systems that we have here.
And over here we have as well different systems for engine management. It's here behind the car, so it's all about engine management, ABS, different sensors, actors, and even here, the camera can catch it. So this one over here, this is our small new invention of a one-cylinder engine. When this is finished, then the students can, after they have understood the principles of engine management, then they can start to program their own control unit and optimize it so that the combustion is better, the ignition timing and all that. So that's really the philosophy of our concept, that we start with the very small things, easy to understand, and then we go higher and higher, more complex, and end at the real car.
The little black box that you're seeing on the back there is actually a dyno, so
yes,
you'll be able to load the system up. And yeah, if you just have a quick look in this room, when we start talking about Unitrain and desktop training, this is one of our training rooms that we use here. So you see that the Unitrain is set up here in a U shape. This is where students normally would get the various hardware and software courses that they're working on and work out in a situation like this. So interesting just to show you what our showrooms look like after normally, just as I said, traveling with one or two pieces of equipment.
Absolutely. But now let's come back to the actual topic of the ADAS systems. So you've seen before the actual car and the actual equipment for calibrating the different sensors of an ADAS system. But now we take a closer look at our different table solutions for ADAS systems. So before we go in close detail, quick overview. We have here our system for ACC, Adaptive Cruise Control. So this is basically the radar system, the radar task. And here, I hope you see it now on the camera. You see this radar sensor, which is actually also mounted, or where the Audi Q5 is equipped with.
So this is actually a radar sensor that we've managed to repurpose into a training system.
That's true.
And we can turn that around and you should see that we've, instead of having the large normal size calibration system, we've put it here so that the students at least get an understanding of how the system works and be able to perform it. So.
Absolutely, and there you see more or less it's one-on-one the system, which we have seen before at the front. There are just a small difference. Maybe someone has recognized it. We don't have this classical mirror down there, but like a special system. How do you say that in English?
This matrix.
Here, yeah, this matrix there, exactly. So perfect is later on we go in more detail how this works or what's the purpose of this. I think most of you can already imagine that. Yeah, there you see the red dot, which is the laser. So, like I said, we have here a real ACC system which completely works and which really gives you hands-on training over here. With each hardware, we always see the course. So the LabSoft course, every system here comes together with the LabSoft course, which explains all the techniques, which gives you an introduction to the training system, and which gives you like the red line for the single experiments which you can do with a training system.
What I just add here, Christian, what we've done is split the screen up now so that you can see there's both the e-learning here. If you want to focus something a little bit bigger here, there's a little divider in between the two screens that you're seeing. You can pull that either left or right and make either of the screens bigger or smaller as you need.
Sounds great. Let's have before we go into the hardware, let's have a quick look then at the software, which we see here.
And so this is kind of like what I was talking about, being able to go into a little bit more detail of the systems. So taking that system understanding, and this is what we find in these LabSoft courses that we have here, is there's experiments that you can do, but there's also a lot of theory which explain why we're doing the experiments or explain the theory which we're working on.
So the main focus of the e-learning courses which we are doing is basically the thing that we are getting less text, but a lot of videos, a lot of animations.
What I just need to add here,
okay.
We're actually we're showing the German version here.
Yeah.
The systems are so brand new that we haven't translated them yet.
Well, they are in translation right now.
But they're being translated now. But we thought because of the chance of being able to do the training, which will work towards personal development, we still wanted to show you because we've got lots of animations that will be explain the systems. But
that's the thing. So forget about the text. I did that already. So just focus the animations and the pictures. And here we start, like you see, with an introduction to what different kind of ADAS systems are on the market or are cars equipped. Our goal is, of course, to get every kind of the most important advanced driver assistance systems into a training systems. But here, of course, we start with a complete overview what is existing right now on the market. And we just want to quick show you a little bit. So I'll just ask you, what do you think is interesting for you? What do you want to show if you learn when we think about ACCs?
So the very interesting thing that I found was the how the radar system works. So I think we're all familiar with how radar works when you have a look at, we're talking about a millimeter or a microwave that's being sent out, and we're feeling or measuring the reflection, how long it takes for the reflection to come in. After having a look at what we've got here, it's actually a little bit different to that. It's not just a simple constant frequency that's being sent out and measured. That wouldn't quite work as well, or it's not as accurate.
Exactly.
So
that would be...
It would be too expensive to get to accuracy on that level. So they've created a bit of a workaround. So perhaps explain how that works.
You jumped into the point then that we are talking about the technique, so how the radar really works. And as you said before, we don't do here an actual direct measurement, it's more indirect measurement. And what will mean, we will see now inside the course. So we start with the technical fundamentals. Also very important to know, where do we find the sensors? So they are not always at the fog lights. They could also be behind the badge of the car. You said an interesting question. So before you said, okay, but when the radar is behind the badge,
how does it affect?
How does it affect? And there you see, especially if you take a closer look to a Volkswagen or to Mercedes-Benz, there you see normally they have their star or their logo as like a metal one, which is glued on the front of the car. But in that case, when you see that there is a radar system behind it, there you see then that they just have a black plastic surface and it's just printed on. So you have no metal ingredients or anything like that, which can confuse or manipulate the radar signal.
So it'd be just like a plastic mesh or something.
Exactly. Like that. And that's when you feel over it and you see there's nothing, it's just printed on this plastic.
Okay. And not always two, like we've seen here, there's two systems or two separate radars. The one we had
at this system, that's right, yes.
Audi, but a lot of systems just use one.
Absolutely, you have one in the center spot, or when you did it like Audi has also that it has one or two, and then there is a master radar sensor and a slave radar sensor. That's important for the calibration. Okay, talking about ACC, what is the most important thing, or what kind of informations do we need? That's first, of course, the distance. So one of the most important information for ADAS, for an ACC system is the distance between your car and the car in front of you.
Not sure if we mentioned ACC.
Adaptive Cruise Control.
Exactly.
Yeah. Well, there are other names as well. So basically, different car manufacturers, they have different. Emergency braking is included in here. So this is like an additional function. ACC system could have this emergency braking, but doesn't need to have it. So that's basically like they boosted up the ACC system. In that system, we have the emergency braking as well.
Okay. Did you have that the picture with everything on there before to have a look at?
That we started with.
Okay. So there's lots of, it's interesting talking about what is included. So there's subsystems, main systems, but it's all a matter of sensor inputs, which they can then employ for various things. So radar obviously is then for ACC.
Different radars, depending on the range.
Lidar is not necessarily a system as such. It's basically a sensor which then helps the various systems.
Exactly. Absolutely. So basically you can say you have an idea of a function which should the car bring, and then through the single sensors, they boost the function up, so it gets better and better and smarter and smarter. So at first you start just with the radar component, then you add the camera, you add the lidar system, and then the normal or the classical idea of the ACC becomes more and more complex and smarter.
Yep.
Okay, but we were at the distance. Then, of course, the other thing which is really important is the speed. So what is the actual speed of the car in front of you? And of course, what we need as well, we are not alone on the road. We need the position. And then the ACC system must be able to choose the right target. We see in that case now the one which is lighted up. Okay, so that means we know now which information do we need, or which information does the ACC system need. The question is now what you already said, how do we measure that? Or how does the ACC system measure that? So there we just start with the fundamentals of the radar technique. For you it was pretty, so as we of course talked everything before in the beginning and just did a test round, you were pretty amazed by the signal. So what kind of signal are we using basically inside the ACC system?
So before we found out about this, did some research, spoke with some experts, I always thought that the signal was just a constant frequency that was being sent out by the radar. But having a look and finding out was quite interesting to find out what actually happens.
Exactly. So basically what is more or less famous is the frequency modulation and the amplitude modulation. And what we are using in the ACC system, or what the classical ACC system is using, is the frequency modulation. So what does it mean right now? When we have a look at this picture over here, we see again the same picture from before. So we have a signal where we have a higher frequency. This is level A, or area A. Then we have area B with a lower frequency, and it goes back to A, and that's going in circles, so repeating and repeating. So what is correct? We have a continuous wave, but we have a so-called FMCW, frequency modulation continuous wave.
Okay.
So we have a change in frequency, but in a continuous signal. It's not like impulses which are sent. It's a continuous signal which is sent all the time.
And so the result is kind of like an average of that, right?
Absolutely, yeah. And here we see it from another perspective, where you see the frequency time on the x-axis and the frequency on the epsilon. And there we see, okay, we have an increasing frequency, like we see it over here. It's increasing, then it's decreasing up to the lowest point, so which is B at here, and then it's going back to its maximum positive or maximum fastest frequency again. And there you see you have a bandwidth in that example of 200 megahertz, which is basically important that you have, as more single steps you have, the more accurate it can be, the whole system. So, and now we come to the measurement, and basically it's not a big deal what we see here. So here you see again, this orange line is showing you the frequency modulation of the signal which is sent, so which directly comes from the car. The blue line is which?
I would say that's the reflection coming back.
That's exactly the reflection which is coming back. And what is the difference between both signals?
Well, you've got a phase shift there. There is a timing shift.
Yes, a time shift, exactly. So they are all on, it's the same signal, just it came later. So from the time on the x-axis, we see the signal arrived later at the radar sensor again.
And that would be to be expected, because if you're looking over a time, obviously that's being sent out and coming back again. So exactly what we would see on a vehicle there.
So, but what the system is now not doing, they do not calculate or measure directly the time between this point, for example, and this point.
So if we're talking about safety systems, obviously if we have to wait for that time for the message to go and back, that would just be wasted time, because then you're already, even if that's 200 milliseconds, that's a lot of time. That's, you know, airbag deployment time and things like that. So there's a really interesting way how they figure it out, but in real time.
It must be crazy fast, absolutely. So, but what we are doing here is just we have the system knows about the different frequencies on each point, and they are just compared with each other, or yeah, you just have to do the math, or the control unit has to do the math. That means it just calculate the frequency difference at this point and at another point, and out of this there is a complex algorithm, but it's a piece of cake for the control unit, and there through these different frequencies it can calculate the distance where the car in front of you is. So how far are each other from distance from each other?
So as we come to expect, obviously we're looking at a frequency here, but that would be a voltage that's being measured within the system.
Yeah.
And so having a look at the voltage of the output signal and the input signal, and that voltage difference is essentially the time difference between the two.
Absolutely. We don't show the algorithm for that because this is much too complex, but you do not know it, or you do not need to know it, because this is done by the control unit within.
And this is kind of like what I was talking about before.
Milliseconds.
At the moment, there's no standards for ADAS. Obviously, there's a lot of talk at the moment about what needs to be taught, but at the moment, most people are just focusing on calibration. And this is kind of what I was saying before about the German philosophy of really going into a theory a lot more to understand how it works. So, and of course, you might say as a teacher or instructor, you might say, look, I don't need to know that. Okay,
perfect.
Fair enough. But our philosophy is that we try to impart the knowledge so that people can make use of that and take it one step further.
Absolutely. So let's jump from the distance to the speed. The question is now, how do we measure the speed? Because we need to know, or the system need to know, are we getting closer to the car in front of us? Do we have the same distance? Are we keeping the same distance? Or is the car in front of us accelerating, and the distance between us and the car in front of us will increase? So and therefore we have.
This is where it gets really interesting, I think.
Yeah, this is what we call in English it was
Doppler shift. Doppler shift.
Doppler shift, exactly. Everyone knows it. Even it doesn't matter at which age. Exactly. But this is always when it happens, when a police car, for example.
Might work. We had problems with our speaker before.
But I'm not quite sure.
We still do.
Exactly. So we have the original whale signal from the US inside the course. That's pretty good for the US. What we want to show with that is that when the car is getting closer to you, you hear a different sound as when it has passed you and get away from you. So what happens there? Actually, we just have a look here at this animation. So the blue person here, that is us, or basically more Daniel. So now the
big belly or what?
No, it's blue. So the car, or what is that?
That's driving to you.
Exactly. It's not a police car. It's more or less like from the fire department. But there you see it's coming through us, and you have a higher frequency because the signal is traveling with the speed of sound, and towards the speed of sound you add the speed of the car.
So you can imagine the frequency is kind of being compressed as it's coming towards you.
Exactly, and this is increasing the frequency. When it will pass you, the car, now you see the car is driving away from you. That means the signal is still traveling with the speed of sound, but now you have to take away the speed of the car, which, if we stay in the example with the compression, now it is like, how you say, widen.
It's being,
spread, more or less. There you see it there. So high frequency, low frequency. And exactly this effect is used for the ACC. Now we're coming back to that example. There we see it right now. Same picture like before, but what is the difference now?
So we've got an amplitude difference within the frequency there.
Absolutely. Now we see the whole signal, which is reflected by the car in front of us, has now a general or overall lower frequency. So that means, staying with our animation over there, the car is getting away from us. So it's accelerating, it's faster than we are, and the distance will increase. So in that kind, it has a continuous acceleration. In the real or in the field, this will change all the time. So it will go lower, 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 lower when it's accelerating all the time. And of course, the distance will go bigger, 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 bigger. And that's the magic behind it. So this is how it calculates the distance and the speed.
And I think the important are these 4 points that you see here.
Again, yeah.
F1, F2, F3, F4. And you can see, so before they were equal, so above the axis, they were equal to what was below. But now we've got a shift in the difference between those. And that is what's causing, or that's how it's measuring.
Exactly.
And calculating that there is not only a distance, but there's also a speed factor involved as well.
Next important thing is the positioning. So as we see here, we have a radar area, and it depends where we are. We have different, a different power of the signal.
Zones, essentially. So.
Exactly. But if you are more away, it's weaker. If you are very close at the car, there it's very strong. So, and then what they are doing, they like Daniel said before, we do not have one radar zone. We have, in most cases, 4 radar zones.
So is that like 4 different?
Exactly. So
that are being radiated out.
So the car knows.
So this, one sensor.
One sensor, and there are 4 transmitter and receivers basically. Okay. And they are slightly different from each other. This is why the car knows when the red reflected, when the green reflected, or when the yellow is reflecting, or the blue one is reflecting.
So that means they would have slightly different frequencies.
Absolutely.
For example.
The problem is what we need. So like I said, this example over here, and this example, it's not important for the distance. This is measured as we've seen before. But this measurement doesn't tell you anything about the angle in what the car is driving in front of you.
So that would be important, for example, if we get to drive on the Autobahn here, which is fun.
Exactly.
Do a couple 100 miles an hour. Well, my car won't do it. 100 miles an hour at least. But as you're going around a corner, then that becomes an issue, because are you looking at the vehicle which is on the left lane or the right lane, or depending on which way you're going around. So it needs to decide like that.
Absolutely. But here in that case, for example, this is the example where the car now absolutely know, okay, we have a strong reflection in the green area and in the yellow area, and more or less nothing in the red and in the blue. So the reflection is must be directly in front of us. Yeah. Exactly. So and this is where we can get, or where the ACC system understands the angle to the car. So there it knows directly, okay, am I straight forward? Am I more to the right or more to the left side? And now it gets really interesting, because now we add another car. And this is what Daniel told before. We are driving now on the Autobahn, and there we see this light blue area. This is like a fictional lane which the car calculates out of the steering angle, out of the yaw rate, and many, many more sensors.
Camera as well, possibly.
Camera as well. It recognized the lane. Exactly.
So like you were saying before, all of these different subsystems add towards making the entire system safer and more accurate.
Navigation data. So the system knows the navigation data is so detailed that it knows, okay, at this part, there's such kind of a corner with so and so much degree. So out all of this information, it can calculate the lane or the upcoming direction in which the car is driving. So that knows when something is in this lane, this is the target where the ACC has to calculate on. And now we go on, and now we see the radar system over there with the 4 areas, radar zones. And now it detects both cars, of course. When we would just have one zone right now, we would know the distance from that object and from that object. But we couldn't say where it is.
Which one is
exactly.
Which lane it's in.
Absolutely no chance about that. And that means now, because we know now, okay, this is in front of us, this is on the left lane. And because of the lane which is focused here, we know that the red car, or the car which is lighted in red, is the car which the ACC system has to follow. Very complex topic, explained in a few minutes.
Yeah, fantastic. Okay. Do you want to just show quickly how the calibration
absolutely
in this system?
So there we just say, okay, what is very important, and this is what you mentioned before, is the angle of the ECC sensor.
That's right. So we spoke about before, there's a lot of these systems are becoming very intelligent now. There's a lot of data. They know what plausible signals are, what implausible signals. There's certain vehicles now that can recognize that if the vehicles, they're only recognizing them at the last minute. So what you can see on here is the brackets have been basically bent up.
Yeah.
And that's from original. So I'm sure there was a recall done on this vehicle at some point. But you can see the vehicle is pointing up towards the sky.
Yeah.
So if all of a sudden the vehicle is recognizing that, whoa, last minute, because it can tell the distance. So if it's telling continuously that there's vehicles only kind of 20 meters away or 30 meters away, 30 yards, that it might say, hey, something's wrong here. You know, the sensor, the signals are fine.
Absolutely.
But I keep getting this signal at the last minute. Something's not right. And so there is certain codes that can be brought in to recognize.
Absolutely. But it also can be really dangerous because the sensor or the system thinks everything is okay.
It's not necessarily going to get a DTC.
Yeah, exactly. Not in that case, for example, because the sensor is maybe calibrated right, but someone has just bent the metal frame here. And it could happen that the radar is looking over the car. So, and that means there is a car, but for the ACC system, there's no car.
Yep.
And we can't think what could happen out of this.
Do you have that picture there of what the radar system looks like inside as well? Exploded view.
Yeah.
Just to put you on the...
But we see that here as well with the...
it's the car.
Yeah.
Just turn the ignition off.
So, give me a second.
Yeah, so
here it is. So here we just see what we have to do then. So when we do the calibration, what we will do over here, we see here in the animations and what we have to do with our hands, basically swap or change the angle of the ACC sensor to the right value, which is given by the diagnostic tester then.
Sure. And the question is, how do you know? It's not like if you do lining up headlights, you've got the little machine which you can do there, or if it's even older than that, you'd line it up against the wall to make sure that
absolutely,
it's right
spot. Yeah.
But this here requires a little bit more precision than that. So
this is right. So we first have a look at this system over here. So, and basically there you see what should happen. So we have on this side our radar system. We have then through these metal parts here our defined distance, which the calibration target needs to have from the radar sensor. And now we have on this side.
Can you see the mirror there as well? Did you?
So on this side now we have our calibration target. And there you see now it looks different to the big one at the car, because here we have the older generation, but the most common generation, where a laser is coming from the calibration target to the radar sensor, and this then is reflected. This one is reflected then on the mirror. There's a small mirror at the defined space over here, and this is reflecting laser beam and bring it back.
Does that mean you see a mirror on the real vehicle as well?
Yeah, when you open it, you will see you have to get away from the plastic covers and all that, and there, for this generation of ACC, will be a small mirror then.
Okay.
And here we see now, okay, it's de-adjusted. It's, yeah, somewhere.
It's meant to be -1, -1.
Exactly. And what we have to do now is that we take the screwdriver. So for the car manufacturers, that are special ones, of course, and then we have to readjust everything. So here, for example, and just see that we are then getting to the right spot. So, So I won't do everything now, but you go to this cruise basically, and then you have to go to that position that it's then at -1, -1, like Daniel said. That doesn't have to be -1 always. It could also be another number. That depends on the car manufacturer.
Every vehicle is different.
Absolutely. It always depends where the laser basically, where the mirror basically is based on the ACC sensor.
Okay.
Okay, coming from ACC, we just said before, there's another system which can make the ACC system even more accurate. And that's the LiDAR system over here. So what does it mean? LiDAR means light detecting and ranging system. So it's like a radar system, but this radar system doesn't work with a radar signal, but with a light signal. And this is exactly what we see over here. So we can activate it. Now we see how the LiDAR system is in operation. Yeah.
Let me just share the screen. Oops.
We go for that. There you see, so the LiDAR basically is working for 360, but in the car, we need it just for the total in front of the car. So same here, brand new course. So it's right now in translation. That's why we do not take too much time for the course, but which is really nice to see. I just have to quickly jump to that page. When we compare now, and that's why it's important to see why the LiDAR is important. When we compare the recognition of the radar, we see the objects are very blurry. When we now add the LiDAR for it, suddenly it can easily detect that this is a person, for example. So the LiDAR helps us to, or helps the car more or less, to get a better understanding and a recognition of its surrounding.
Was it the case also that LiDAR works better in certain conditions, foggy conditions, for example? I think that's better than radar.
The radar, the problem is with the radar system, as soon as you have some metal object somewhere and all that, that could lead to problems with the radar system. The LiDAR system has other problems because it is a light system. It has problems with weather conditions. So it is weaker in weather conditions, exactly. Because light can be, everyone who has activated the high beam in a foggy area knows it, that this leads to reflections. Therefore, the LiDAR has problems with weather conditions where the radar doesn't have problems, but the radar has problems in areas where everything is full of metal, for example, where are a lot of reflections.
The Tesla's quite famously said that they don't believe that LiDAR is a part of their sensor suite, so they don't use LiDAR at all. They're using just radar and cameras.
Okay, as Tesla want to do it.
Yep.
I just remember the white truck. Okay, perfectly. So there's again, like in the ACC course, we have a lot of animations, how everything works. The recognition of the surroundings, for example, there we see it here. So it really can detect all the single components. Where the radar just detects an object, the LiDAR can detect what it is, or can, through the detection or the recognition of the sharp shapes, the ACC system then knows, okay, this is a car, this is an obstacle, this is a traffic light, or whatever. Again here, what is the most important part? What we have to do?
Calibrate.
Calibration, that's right. So we open the LiDAR monitor over here.
So this is a monitor that you've got inside the e-learning as well?
Exactly. So I go like that. And there we see now the complete recognition of the car in front of. And as we see, when I put now my hand here, I block everything.
So what you're seeing there is all of the things. Can we change that to say 360 or
yeah, of course.
just to see? So there you're seeing
this would be for both
our hands. So you can really see everything that's going on there. Absolutely.
You can show the cursor then where you see the different distance, what they have. So we have now a complete view of 1 meter. So 100 centimeters over here. And now when we have a look at this system, we can do the calibration as well. So we have to put 15 centimeters and put the calibration target over there. And this is now what we directly see over here. That means, how do we recognize that calibration then? We have different holes over here. We have a very small one, we have the very wide one, which is the correct one, and we have a wider one, which shows that the calibration or that the sensor is too high. So right now we have again here our screw, our calibration screw, where we can change everything. So when we now get too close, we see we are now at the lower part where we just have the small hole. So when we now get higher, we see this is now our perfect shape. And when we go more higher.
So this here in the background is actually the car behind.
Exactly. Yeah, this is the car. There we see how far it is away. So, but now we are too high. So I go back. And now you see, now it's in the big hole over there. So and this is the right. Stages. Exactly.
3 stages of this calibration target where it's got different holes. So, and that's what you see in the workshop for Lidar. Is that
absolutely? That's also the thing where how you can calibrate a Lidar. Of course, there also can be different methods from car manufacturer to car manufacturer, but this is one common solution how it's done. So, and then furthermore, really to understand what Lidar can do and what it can't do, we have different kind of reflection targets over here. So what we see here, what is that? I see
plexiglass.
I clearly see Daniel, and we are right now here again. We see the calibration target here. So everything what is here should be in front of the calibration target. And we see it depends on how I hold it. We have different reflections even at this very clear surface. But when it's absolutely,
it's a little bit dirty too.
When it's absolutely clear and absolutely straightforward, it will go through. So the light won't be reflected. Yeah, do the best. There we see even, yeah, very good. But there you see it basically go through. There are some dirt spots on it, and that will lead to reflections, of course. Then we have, of course, what you said. I don't see you anymore. The foggy conditions. And there we see we get in trouble because the small raindrops in the air or water drops will lead to a reflection of the light. Yep. And of course, when we have absorbing material, we see that blocks everything. So while we here have a little bit, it goes a little bit goes through, here is nothing anymore. It blocks the whole thing.
Hand, which is
basically, for example, yeah. And now we have another very important thing. This is our mirror. And the funny thing is, when we now show the mirror, we have now a strange appearance of the radar. So what could that be? So it's not like that we are blocking something, but now we have a full reflection, but now we have, it's brought to another direction. So we are going not straight like we do here. When we put an angle into it, it will reflect the light over there to the wall and reflect it back. So this will completely manipulate the system. Or in that case. So that means on the radar, you see it now that it doesn't detect because I'm going now here 1 meter, nothing is here anymore. Daniel tries, try to put, oh wait, go away that we get it clear. So and this is now, Daniel is now the obstacle and not what is over there. And now even Daniel can't really disturb it anymore because now it's reflected to the roof. And there you see the system doesn't detect any obstacle because it's manipulated through a mirror. Very, very easy and nice to understand. From your side, more questions to that. So like I said, this system won't normally not be used just for ACC. This is used in conjunction with the radar and with the front camera. And together you have a very powerful ACC system then.
Yep. Don't think there's any questions. We'll open this up to Q&A after as well. So we'll unmute everyone and answer any questions if you have any.
Absolutely.
Perhaps one of the last things we'll have a look at
is
that's literally a prototype that we have here.
Brand new. brand new. It just arrived more or less. So it's for us, it's also a little bit of, see what we have here, because like I said, we are just giving in the ideas, putting on the development, and this is now the product, what we got back. And what do we have here? This is the lane assistant. What is the big difference to the other systems? It's not about the distance measurement. It's now about understand and see what's in front of you. And in that case, especially you want to see one special thing. We want to see the lane where the car is driving in.
So I think that's a really important thing here as well, is lane markings. So this is highly oh yeah, got to share the screen on this one as well. Can you just stop that one there, please? Okay, sorry. So this one's highly dependent on the camera, of course. So if we don't use the camera, then yeah, it's not going to be possible. And then obviously using the lane markings. So if the lane markings aren't there on the vehicle, it will also, on the roads, it will also be very difficult or shut down.
Just as a question, because the quality is a little bit blurry here. It's good over there.
Yeah.
Okay, that's all comes down about the internet connection. I hope it's getting better now. Very good.
Okay.
So I think, but see what you need to see. So what we have here now is our lane basically. And what we can do now is we can now activate our lane assistance. So basically everything's activated, and what we have to do now is to change the detection threshold. This is now how the car or the system sees this lane markings over here. And that is what?
Can you pull that across? We're not using.
No, you just have shared this one.
All right. We'll just switch it over. Can we?
So perfectly. There you see now the marking threshold. So, and that means, and this is exactly what happens inside the real car, it has to be adjusted this way that it detects all the lane markings. And we have here very dynamic conditions, because this is again about the weather conditions, light conditions, and also the quality of the signs. This is a brand new street where we now have a bloody old street. So maybe the lane markings are dirty or just destroyed somewhere. And this is where the system always needs dynamic to change everything and that it recognizes the lane markings. And we see here when we have a wrong one, the car doesn't detect the lane anymore. When we change the threshold, everything becomes more clearer, and we see now there is the lane. And now we basically have the complete lane assistance over there. Daniel's just changing everything. So,
and what we've got on the system here is there's feedback. You can see that the system is, if you're needing to change lanes or turn a corner, anything like that.
Yeah, and we have two different things here. We have the lane departure warning. So that means you see it here with the marking. When we control it over here, we get now the red warning, and we have also a feedback, haptic feedback on the card, which is, you don't see it, but I don't see it either, but I can feel it. So when I touch the steering wheel, for me, it's like that I feel like a vibration right now. Now you have, good idea. So, okay, I hear it clearly here. Daniel is hearing it as well. So that means we have to go back now in order that the warning stops. As well, just as a side information, we have also a hands-on detection. So that means when we stop having our hands on the steering wheel, in order like using an autopilot function, that the car stays in the lane itself, the car will bring out a warning somehow, that we hear it, and it becomes more faster and faster as long as we do not touch the steering wheel. And when I touch the steering wheel again, it detects the hands is on, and it stopped the warning. So, but this is like the normal lane departure warning. We can now switch to the active lane assistant. And there we see early intervention or late intervention. What does it mean? We see it even more accurate in the video then, but just to give you an idea. So when we get to the borders, the car is taking us automatically again to the middle.
I think this is also interesting, perhaps interesting for you who are watching, to see how we go about developing these training systems. So this is how the system started out, with simply a picture on here that we could show how the system, what the system is looking at when you see the machine kind of vision of the signs. And we had the system developed, and then we thought, actually, why are we using a static picture when we can use a rolling video? And so during the development, we were able to turn it around into using a video.
Absolutely. And I just want to show here, before we switch to the video, again, we have the late intervention, the early intervention, which we clearly see in the video later. That means the early one is, as soon as we get out of the sweet spot, it takes us back. And when we have the late intervention, we can go up really to the edge of the lane.
Why would you bother having late or early intervention, Christian? What's the difference?
That's just what the car manufacturers have did.
Wouldn't you prefer to have always early intervention? Doesn't that make sense?
Sometimes the people do not like it because they have always like an intervention or from the car, and there are just people who do not like it when the car. Different manufacturers, but this is
early means faster process.
It holds you
like that as well. So.
Like Skoda has, for example, this version as well, which I have driven. When you take off the hands of the steering wheel, as long as the system stays active, it keeps you really in the middle of the lane, and that we see now perfectly when we go to video. So that means we have now active lane assistance, early intervention, and when we now play the video, we see it keeps us in the middle, more or less, of the road.
So this is now the hardware is interacting with the software here, right? So you can see the...
Exactly, and it really keeps us in the middle, so there's no warning at all because the car keeps us in the middle at the sweet spot. Also, second video, there it's the same. And when we now go to late intervention, is
for a second, I'm trying to see the. So
okay, yes, intervention.
Is showing the steering wheel as it's turning around there.
Exactly. But now when we go to late intervention, there we see now we get more to the borders of the road before it takes us back. So it's like more pendling, and it's not like that it always keeps us directly straight when we go to early intervention. So I'm quite impressed by what the system can do. If we just see, that's a lane system which is normally just working in the driving car. We have here now in our training room just on this small table.
So what about calibration if we look at this thing for a different
calibration
system?
Also very important, but as we now not calibrate the radar but a camera, it looks a little bit different. And there we see the target. Oh, that was by accident now. We are directly in the sweet spot. So there you see on the left side again how it recognizes its surroundings, and there we see everything is good. The adjustments are perfect, that it really recognizes the conditions. Why is everything black and white? Because this has the sharpest contrast to each other, and that's why it's easy to understand. And what we have to do now, for example...
Just change the threshold there.
No, what Daniel often do, it brings stuff out of order.
Yeah, but what we'll do is just...
Okay, you bring it out now, but I just want to show when the camera is now, something happened to the camera, for example. Or you have built in a new camera, and it's of course not exactly at the same spot like before. What you have to do now is, it's not like that you have any screws at the camera systems where you do a mechanical...
These are often built in, as we've seen before with the...
Exactly. What you do here now is that you do it within the tester, the camera, so it's a software calibration, where you take now the camera or the digital perspective of the camera to the right angle. And there you see We are right now in the sweet spot. It's calibrated, and now we know that the camera is correctly, has a correctly view on the road, and the system is calibrated.
Right.
So it's not about magic. It's just you need to know what you have to do. You need the right equipment for it, and you need to know how to use it. And that's basically all for the systems.
Okay. Well, there is one over here which maybe we haven't focused on today because it's take my phone off. Should be charged now. We've got traffic sign recognition here.
Exactly.
Now, we haven't shown that one because obviously traffic signs look a little bit different in the US. Let me just turn this screen off. So traffic signs look a little bit different in the US. And as part of doing this, we had to train the algorithms to understand what they're looking at here. So it's not just a simple case. It's amazing how difficult it was to develop these systems.
Absolutely.
The algorithms that go into just recognizing the different numbers. So are you able to show that here, or I'm not sure. I haven't used this one myself yet. So
now that's also additional software.
Okay.
But like basically it's the same what you have seen with the Lidar systems before. It's about to recognize the pattern and the differences. And there's just a program pattern which recognizes, for example, the German road signs. This is different, of course, to the US road signs. There you need another algorithm which detects then the US road signs. But basically it's the same thing that you really see. So the camera
is exactly the same.
Detects the shape. And for example, there you see, of course, if you put a sticker on the traffic sign, there is a way, or that you can manipulate the traffic sign up to a certain point, but if there's too much distortion on it, it won't recognize it anymore.
Exactly. And I think there's certain ways that they make it. So for example, the 8 and the 30, things like that, there's certain tricks about them that they can
absolutely
determine the difference.
And just what is nice to know about that, of course, the same camera who's doing the lane assist is doing also the traffic recognition. Traffic sign recognition.
Okay.
Perfect.
All right. Well, what we'll do now, if you've got any questions, please feel free. Not quite sure what we'll do. If you put your hand up maybe, and we can try and answer any questions. We're open here. But otherwise, I'd just like to say thanks very much.
Absolutely.
This is our first of 3 webinars that we're running this week. So tomorrow we'll be looking at the ASE L3. So over in the corner there, we've got our high voltage area. Perhaps we can just have a quick look over here. We'll be having a look at more detail about high voltage. Switch to, exactly.
So this will follow up tomorrow.
So high voltage systems, truck train, high voltage electric trucks. And this one here, high voltage batteries, which we'll be looking at on Thursday morning as well. So yeah, apart from that, you should have the link for those as well if you're interested in joining in. But yeah, apart from that, hope you learned something today and it was interesting for you. So
this is also the start from our ADAS program. Of course, it's not the end. For the future, we will develop more and more. And the aim is basically to get to that autonomous driving, to this complete vehicle. Yeah, but so this is the start where we have the most important ADAS systems now on the market and which we can bring to you into the classroom. And you have seen how easy it is. We have done now in this webinar just 3 calibrations, different calibrations. We absolutely hope that you've liked it.
One last thing about calibrations, you mentioned too that some vehicles are doing self-calibration, certain degree of self-calibration.
That's right. That's also mentioned in the ACC course. There are cars like BMW who are doing not a static calibration, but a dynamic calibration. And what you have to do there is you have to grab your diagnostic tester, put it on, start the calibration process, and then drive maybe for 30, 40 kilometers. And then the radar will calibrate itself during driving. This is, of course, not so important for training system because everything is done by the car itself, but it's mentioned in the ACC course and also described there.
Absolutely.
So from that point of view,
for those of you with CAT, so California Automotive Teachers, we'll contact you and put you in contact so that you get your hours, your allocated training units for joining this. We've also had some other people join in. We thought, why not? Because we're doing
Absolutely.
it. So it doesn't hurt if more people want to join in. Have we got anyone asking any questions yet or raising their hands? So last chance to raise your hand if you're interested in asking any questions. Just switch on your speakers and ask away. So we'll wait a couple of minutes for that. Yeah, I'd like to say thanks very much for joining us here.
Absolutely.
In our, showrooms for a change.
I hope you had a great time, or we gave you a good start into the day. You get some interesting information. We are open for your feedback. Just let us know what you think. And then we just say, have a nice day.
Yep, so you should have our emails there as well. Just send an email, send in chat. If you need any help with anything, always happy to help. Yeah, and hopefully we'll get to see you either tomorrow or Thursday.
Absolutely.
So still no questions, so we're going to say goodbye.
Have a good one.
Dinner time.
Bye.
Ciao.